Hello, my name is Ed Malthouse, and I'm going to be teaching Marketing Models 2 this year in the fourth quarter for IMC students. I've decided to focus on a very important topic in business analytics that we really don't have enough coverage on as of this time. So this course is an effort to remedy that. The topic is time series forecasting models. So let me start by saying that every business statistics textbook on the planet will have at least one chapter on this topic. And a lot of business schools, I'm going to say most business schools, will even offer a more advanced whole course on this topic. So it's a fundamentally very important topic in business analytics. I've chosen a great textbook for this. So I love this textbook. It's by Rob Heinemann, who is the editor of the Journal of Forecasting. He's a professor at a business school, so he kind of knows how to teach really well. And the text is just a joy to read. So I think you're going to enjoy it as much as I've been enjoying it this summer. Okay, so what is forecasting all about? Forecasting really is about three things. So we have data over time. So it could be our sales every month or every quarter. We may want to do some combination of three things. So the first is description, the second is prediction, and the third is prescription. So description is all about trying to understand what's happening in this time series. So during what times of the year or times of the day or times of the week or whatever, do we sell more? At what times of the day do we sell less? That would be an example of something called a seasonal effect that happens regularly. Are there trends? So are sales going up? Are they going down? So we're going to look at how to study trends. A third part of this is, are there cyclical effects? So cyclical effects don't occur in any regular time period, but things go up for a while, then they go down for a while. So this often follows business cycles. So when we're in a recession, we tend to sell less stuff. When the economy's booming, we tend to sell more stuff. So that's the description part of this. The second part is prediction, where I need to know how much am I going to sell next month. I need it for planning purposes. How much do I need to manufacture in order to have enough product in the field to meet demand? Or how much am I going to sell next year? That's the prediction or the forecasting goal of this class. The third kind of use of time series models is for prescription. Okay, so prescription is all about trying to understand how actions that my firm takes affect this time series. So one of the classic examples of this would be the marketing mix. If I were to change my promotion policy, change my price or whatever, what effect is that going to have on my sales? So we're going to cover all three of these questions in the class, and we're going to cover them using different approaches. So let me just briefly go over the course outline. So first week, what we're going to do is cover the basics. So how do you do this in R? By the way, R has a fabulous forecasting library that makes all this extremely easy. So how do we prep the data? How do we load it into R? How do we look at basic descriptive plots to understand what's going on? Second week, we're going to move on to modeling approaches and how we use regression models to study time series data. So it's really important that you have a solid grasp of regression before you take this class. Make sure you've had the data science class. I'd recommend having taken my machine learning class. If you didn't take my machine learning class, you can watch the videos to get caught up on that. But I'm not going to teach regression in this class. I'm just going to teach the time series aspects of regression, assuming you already have a pretty good grounding of that. We're also going to cover what are called decompositional methods. So decompositional methods are really good for the first task, which is describing a time series. From that, we're going to move on to one of my favorite and I believe most important approaches, which is exponential smoothing. This we're going to find is one of the best methods for the second question of prediction and forecasting. Week 4, we're going to move on to a different approach, which is the Box-Jenkins or ARIMA approach, which is, again, one of the best approaches for forecasting. You can do a lot with it for a description as well. And then in the last week, we're going to cover dynamic regression models, which get at the third task, which is the prescription part. And what you're going to see is we're going to be combining aspects of regression with aspects of time series, like the ARIMA models, in order to make inferences about if we did something, what happens. All right, so that's an overview of the class. Prerequisites again are make sure you've had the data science fundamentals class that you took in winter, hopefully, and it's good to have my machine learning class. The format of the class is going to be online. We're going to have very similar format to what I had in machine learning. You will be working in teams, trying to get as much interaction with other students as possible. We'll have a weekly sync session. I'll make sure that sync session is at a reasonable time, both here in America and in China, so that it will work in both places. We're going to have a lot of your turns. I've been working on those your turns this summer with solutions that give you a lot of practice. Then we're going to have 2 projects. There'll be one business-oriented project. I'm still working on the details of that. The second project is going to be to forecast, this is going to sound really morbid, but COVID deaths. So as of the last day of class, week 5, you're going to have to make a prediction for the number of COVID deaths a month out. And then at the end of the quarter here at Northwestern, we'll know the answer to this, and we'll know who has the best forecasting model. So very timely topic, and I think fits very nicely with the class. Finally, I want to address why I've moved this class to online. I know I ran a survey in spring, and the overwhelming answer was it would be great to have some in-person component of this class. I originally scheduled it so that there would be an in-person sync session available for those in Evanston. I've decided to cancel it. Here's why. I don't have perfect data right now. I'm going to know a whole lot more in a couple weeks once other universities start opening up. But I've been tracking this very carefully, and I believe that in-person is not going to be a good idea. So just, this is a data class, so I better give you some evidence of this. This is in the New York Times today. Talks about some schools in Indiana that are opening up, and they within hours had to close down. This is a chart showing what happened when Israel opened its schools and how COVID cases spiked. Here's another article in today's paper about how some Georgia summer camp opened up, and the virus spread very quickly. So I don't think it's a responsible thing to do to have in-person classes. Maybe in a month I'll change my mind on that as we get more data, but we're not going to do in class for that reason. With that said, I really want to meet all of you. I really do. And so I think the responsible way to make that happen is to have office hours at my favorite place on campus, which is the Lakeville area. So I'm going to be scheduling weekly office hours at the Lakeville area where we can be outside, we can have masks on, we can be 2 meters apart, and that'll give me a chance to achieve the goal of at least meeting you and talking about time series in the most beautiful environment on campus. So I really hope to see you this fall, and I think you're going to love this class. I sure have enjoyed preparing it.